and write in those notebooks. You have noticed that we can write basic operations like multiply, divide, and this works. We can also write floating point variables or variables in scientific notation. So, for example, 3.5 times 10 to the power of 4. That would look like 3.5 E4. And as you can see, we have correctly 35,000. And we can use brackets around parts of equations, like this. So 5 times 6 divided by 3.5 E4 plus 4 minus 2.3. And if we execute this, we will get some result. Similar to normal math, that would change the order of execution for this equation, and the value also changed because of the brackets. And of course, you can import math module, as we did before, and do math operations. For example, we can take exponent of some number. For example, that would be e to the power of 3. You can find information about these functions online at site docs.python.org. This page describes in detail what you can do with each and every of the math module functions. And of course, with these equations, you can still apply normal rules and combine them into larger equations as you would do normally. In addition to the standard 4 operators, Python has operator of exponentiation. It is denoted by double asterisk. For example, 2 to the power of 5. Modules operator. It is denoted by percentage mark. So 8 modulus 3 is 2. Floor division operator. It is denoted by double forward slash. That would be 2. Python also has bitwise operators. They are AND. That is denoted by ampersand. And we can try it with 5 and 3. And the result is 1, because 5 in binary is 101 and 3 in binary is 011. So AND bitwise would be 001, which is 1. Similarly, we can have OR operator, which is denoted by single vertical pipe. So 5 or 3 is 7, which is as we expect it to be. And then exclusive OR, which is denoted by cap. And 5 XOR 3 is 6. And finally, bitwise NOT, that is denoted by tilde. And NOT of 5 is -6. But if you understand the maths behind integer numbers and representation of integers in binary system, then you will see that this is correct. Two more operators that are very useful, although they are not exactly logical bitwise operators. They are zero fill left shift, that is denoted by double less than sign. So we can shift our 4 by 5 positions, and we will get 128, which is expected. And then signed left shift, that is denoted by double greater than sign. We can do reverse operation by shifting 128 5 positions back to the right, and we get 4. Again, please refer to the mathematics on how bitwise operations work. We are not going to discuss this in this course. Another groups of operators that are available in Python are assignment operators. And this is where we have to touch a little bit the next topic, the variables. So in Python, you can save things to a variable by typing some symbolic name that it must start with a character or underscore. Let's say some underscore var, and then assign it to some number, let's say 5. And now we have some var that is equal to 5. And if we just type it here, we will see that it has value of 5. So this equal sign is single equal sign, is operator of assignment. Python has combinations of normal mathematical operators and some bitwise operations with this equal sign. The idea is that instead of writing some var equals some var plus 1, if you need to self-reference this variable, and that will result obviously in some incrementing number all the time, you can type the same thing simpler and shorter by typing plus equal and then just keep the right hand side argument. So this operator takes this variable, adds 1 to its value and writes it back. And for this we have operators for plus equal, minus equal, multiply equal, divide equal. And you can go on with other operators. For example, you can have bitwise or equal, and so on. Finally, to produce logical tests, Python offers comparisons, logical, identity, and membership operators. Comparison operators are equal, that is denoted by double equal sign, and we can check that 4 is equal to 6, which is not, and as you can see it returns Boolean value, false, and we compare 4 to 4, then we get true. So this operator definitely works. Its opposite, not equal, this is basically inverse operation. If we compare the value to itself, then it will return false. If we compare it to some other value, then it will return true. And standard things in logical comparison: operator greater than, that is a single greater than sign. And we can check if 4 greater than 5, which is not, or less than 5, which is true. And there are combinations greater than and or equal, and that will be true for 4, whereas 4 greater than 4 will be still false. And similarly, we have less than or equal. Another group are identity operators, and we will go through them in more detail and their use when we will touch lists and dictionaries. But for now, you just need to know that the identity operators check if two variables are or are not the same object. And this topic we will discuss in detail later. It requires some special knowledge for you to understand how that works. And finally, the membership operator will check if a sequence is present or not present in the object. For that, we will need to understand how lists and dictionaries operate and what they are. So we will not touch that here as well. The only thing that you should know is that if you have some kind of list, and this kind of list, for example, we have a list in, we can check whether some string is present in this list using operator in. So left-hand side of this operator is what we're looking for, and the right side is object in which we're looking. And this returns true, but this gibberish will not return true because it's not present in. And there is opposite of in, not in. Works exactly like in, but in reverse. So it returns true when something is not in target object, and then it returns false if something is. And finally, and one of the most useful things, normal logic operators, not bitwise ones. And, or, and not, they are typed as and you can see green syntax highlight, or, and not. Of course, they will not be correct syntax because we need to provide some operands to them. But these are just normal logical operators. For example, if you will say true and true, you will get true. If either of these is false, then we get false. Similarly, or works as intended. So you need to have both of them false to have or going false. And not is just inverse of whatever is on the right side.